Hello, good afternoon and welcome to C2 Live. We're looking at the June 2010 paper. Okay, question 1. We're given a formula that y equals 3 to the x plus 2x, and in part A we're asked to complete a table giving values of y to two decimal places. Well, when x is 0.4, y is 2.35, when x is 0.6, y is 3.13, and when x is 0.8, y is 4.01. As you can see, I've laid out my working, showing the substituting I'm doing, and you've got to make sure that you actually round those values to two decimal places. Part B asks you to use the trapezium rule. So basically, the formula is that the integral between a and b of y dx is a half of the height, and in the brackets you have 1y0, which is your first value of y. You have yn, which is the last value, the nth value of y, and then you have 2 of all the other y values added together. And it's basically lots of trapezia added together and factorised. So, the height is 0.2, that's the difference between the x values. The first y value is 1 and last is 5. So in the brackets we have 1 plus 5. And then we have 2 lots of all the other y values, 1.65, 2.35, 3.13 and 4.01. When we stick it all into the formula, we have half times 0.2 times the 1 plus 5 plus 2 lots of all those other values, and then when we simplify it we end up with 2.828. Question 2. It's a remainder theorem question to start off with. We're given fx as 3x cubed minus 5x squared minus 58x plus 40, and we're asked for the remainder when f of x is divided by x minus 3. The remainder theorem states that if we take the value 3 and substitute it into that expression, then that will give us the remainder. So, f of 3 is 3 lots of 3 cubed, take 5 lots of 3 squared, take 58 lots of 3 plus 40. Working it out, we get minus 98. For the next part, we're told one of the factors is x minus 5. You can use long division, but I've chosen to do a sort of quicker method, which basically looks at what the terms need to be to make that original expression. So, we've got an x, but we want 3x cubed, so obviously we'll need a 3x squared in our quadratic. We've got a minus 5, but we need a plus 40, so therefore we need a minus 8 at the end of our quadratic. To find out the x term in our quadratic, we can go about 2 ways. We can look at the x squared terms or the x terms. If we look at the x squared terms, we've already got minus 5 times 3, which is minus 15x squared. But we only want minus 5x squared, so we need to add another 10x squared to our minus 15x squared. We've got an x in our linear bracket, so we need a 10x in our quadratic bracket. And then to finish off, we have to factorise 3x squared plus 10x minus 8, which is 3x minus 2 and x plus 4. Putting that equal to 0, we get 3 answers of 5, 2/3 and minus 4. Question 3 is a differentiation question. In part A, we're simply asked to find dy by dx, but that does require us to remember that we need all the terms with indices, and root x is x to the half. So we have y equals x squared minus kx to the half. To differentiate a polynomial, we multiply by the index and then subtract 1 from our index. That will give us 2x instead of x squared, and we'll get a half kx to the minus a half for our other term. For part B, we're told that given that y is decreasing x equals 4, find the set of possible values of k. If a function is decreasing, it means that dy by dx is less than 0. So we take our differential of 2x minus a half kx to the minus a half, and we substitute our value of x equals 4 into it, and we put it less than 0. And after some rearranging, we end up with k being greater than 32. Question 4 is a binomial expansion question. In part A, we're asked for the first 4 terms of 1 plus ax to the power of 7. And we're asked to put each term in its simplest form, but we should be doing that anyway. Okay, it's 1 plus ax to the power of 7. Now in general, we'd have 1 to the power of 7 plus 7 lots of etc. Here we can just do 1 to the power of 7, which is 1 straight away. The next term is 7c1, which can be written as 7(1) in brackets, ax to the power 1. Then the next term is going to be 7c2, ax squared. And the fourth term will be 7c3, ax cubed. Evaluating 7c1, 7c2 and 7c3 on a calculator, we get 7, 21 and 35. And getting rid of the brackets for the ax squared and ax cubed, we get a final answer of 1 plus 7ax plus 21a squared x squared plus 35a cubed x cubed. For part B, we're told that the coefficient of x squared is 525, which is the same as the 21a squared we wrote down in part A. So 21a squared is 525, divide by 21 to get a squared is 25, square root that to get plus or minus the square root of 25, which is plus or minus 5. Question 5 is trigonometry. It starts off with 5 sine theta equals 2 cos theta and asks us for the value of tan theta. If we remember that tan theta is sine theta divided by cos theta, then we can divide by cos theta to get our tan theta, but we also need to divide by the 5 to get tan theta equals, and it will be 2/5. In part B, we're asked to solve an equation between 0 and 360 degrees. 5 sine 2x equals 2 cos 2x. If we compare that with what we were asked to do in part A, we have that theta equals 2x, and that means that tan 2x is 2/5. Now, because x needs to be between 0 and 360, that also means that 2x will be between 0 and 720, and we're going to get 4 answers for the equation. So 2x is the inverse tan of 2/5, which is 21.80. Using our cast diagram, we have an angle at 21.8 degrees in the A section, but we also have an angle of 21.8 degrees in the T section, since 2/5 was positive. So 2x is 21.8, going around another 180 degrees, it's 201.8, going around again, it's 381.8, and finally 561.8, and now we can divide those all by 2 to get 10.9, 100.9, 190.9, and 280.9. Question 6 is another trigonometry question, but this one's about sectors and arc lengths. So in part A, we're asked for the length of the arc AB, and we can use the formula arc length, which is S equals r theta. Theta has to be in radians, but we have an angle of 0.7 radians, so it's simply 9 times 0.7, which is 6.3 centimetres. For part B, we're asked for the area. The formula is A equals half r squared theta. Again, theta is 0.7, r is 9. Putting it all together gives us 28.35 centimetres squared. We're told that the line AC is perpendicular to OA, and then we're asked to find the length of AC. That simply means that it's a right angled triangle, and then we can use tan x equals opposite divided by adjacent. AC is the opposite, so that means it's going to be the adjacent times tan x. The adjacent is already known as 9, the angle is 0.7, and 9 tan 0.7 is 7.58 centimetres. Finally, we're asked for the area of the shaded region. We can work out the area of the triangle simply enough using half base times height. We've got the base and height as 9 and 7.58, so the area of the triangle is 34.113. The shaded region is going to be the area of the triangle take away the area of the sector that we found in part B, so that's 34.113 take away 28.35, which is 5.76 centimetres squared. Again, that's correct to 2 decimal places.